Okay, so basically, here's what you need to use the trapezoidal rule. This is exactly what I just said on the board, that the height of each trapezoid is the length of the subinterval. So if you take a look, and if we've divided it into so many subintervals, so if I take one of these as the trapezoid, right, you see this is the height, and it's the length of the subinterval. And how do you find it? We do the interval divided by the number of trapezoids, right? And then the bases are the function's value at each base point. So take a look here. This is base 1, and this is base 2. How do I find how long base 1 is? What do I do? It's f of x at that point, and then this is f of x2 at that point. Okay? So remember how here we were plugging it into the function, right? That's exactly what we're going to do. Yeah.
Why is it f of x?
Well, because like the value here, it's like the first x value, and this is the, so this would be like x equals 2 and x equals 5. Yeah. F of x2. So like if this is f of x, because this is x, then that's like x2, f of x2. So basically, yeah. So whatever x is here, it's f of that x. Whatever x is here, it's f of that x. Okay? All right. So this is notation that is in section 5, because you would have done 2, 3, 4. I'm going to skip over the notation right now. When we learn the notation, we'll come back and you'll see exactly what it means. All right. So let's go here and do one of these fabulous examples. Correct. We're skipping around this chapter. We're going to come back though. Yes?
On the previous page, it said that you can also do like LRAM and RRAM.
Yeah, we'll come back to those. Okay. So here we go. We have a region R between the graph of the function. Oh, it's twice. Y equals root 2x and the x-axis. All right, so let's just draw y equals root 2x. When x is 0, it's 0, and it's going from 0 to 8. So when x is 8, how much is y? It's 4, right? It's the square root of 16, so it's 4. So I'm just going to do a rough sketch that looks like that. No, just do a rough sketch. Now it says sketch R and use trapezoidal rule to approximate the area under the curve using 4 subintervals of equal length. So now, subintervals of equal length. So how much is the height then? The height is going to be 8 minus 0, right? That's a distance of 8, divided by 4, so 2. Right. So now here's how it's going to look. So I'm going to go every 2 spaces like this. Okay?
That's why I had trouble on the homework, because I was forgetting what you had to do to, like, yeah, because I just had, like, on all the practice ones, we had 1.
Right.
When we got to the other ones, I didn't know if all
Right.
of them.
So you go from So you go from starting to end. How many units is that? Right. From 0 to 8. That's 8 units divided by 4. So the easiest way to do it is that minus that divided by the number of rectangles or trapezoids. So now I'm gonna go slowly on this one. And what I'm going to do is I'm going to try to color code them. So this is trapezoid 1. This is trapezoid 2, 3, and 4. All right. So let's find the area here.
Are we always going to only have 4?
No. Okay, so let's do the area. So for the first triangle, for the first trapezoid, right? Here's the trapezoid. It's going to be half times 2 times what?
0.
Base 1, which is 0, plus base 2. How much is base 2? So base 2 here is f of 2. It's half because it's half times height, base 1 plus base 2.
Oh, yeah.
Half is from the formula. Half times height, base 1 plus base 2. So how much is base 2 right here? It's f of 2, which is the square root of 2 times 2, 2. Yeah.
You said you're doing a rough estimate, so can it be different for everyone? For the base, because we just know that.
I do a rough estimate to draw the graph, like for the actual sketch. But once I do that, I know I'm going from 0 to 8. So I know that each one of these is going to be a length of 2.
Yeah, well, that's for the height, right? Not the base.
So that's the thing. Now, if we have a trapezoid, you see how a trapezoid, when it was like this?
Yeah.
It's base 1, base 2, and height. When you turn it over, height is the distance between the two parallel bases. So even though it's horizontal, we call it height. These are the bases of the
The
trapezoid.
lesson we learned yesterday, it wasn't anything with like a 1/2, and we had to plug it in.
No, the 1/2 came from like the formula, like the equation. Y.
Oh, I was
Yeah.
making sure it's
Okay, so are we okay with how we got the first trapezoid?
Yeah.
The area of the first trapezoid. Oh, you know what? I was gonna color code these.
Can we just make the whole thing what we do for the other ones, like take out a 1/2 and then put.
I'm gonna do it later. This is the first time I'm doing it like this. Okay, so that's the first one. Now, let's do the second one. It's going to be half times the times the height, times base 1 plus base 2. So now look at trapezoid number 2. What's base 1? 2. And what's base 2?
Add all 4 areas together.
Yeah.
No, you have to plug it in. Yeah.
You have to plug it in. So here x is 4. So it's going to be the square root of 2 times 4, root 8.
Should we leave it in radical form, or should we simplify that?
Right now I'm just going to leave it like that. Just go with what I'm doing. Right. Okay, next, the third triangle is going to be half times the height times, what's base 1 for the third triangle? Root 8 plus, here, the square root of 2 times 6, root 12.
You don't have to.
For now, no, because we're going to get the decimal later anyway. So,
Can you explain how you're finding the base 1?
okay, take a look here. Look at trapezoid 3. This is base 1, this is base 2. Base 1 is at 4. I plug 4 into my equation. The square root of 2 times 4 is the square root of 8. Here it's 6, the square root of 2 times 6. Okay? And then, so then the last one is half times 2. Base 1 is root 12 plus 4. Yeah. Yes.
Why are we multiplying everything by 1/2?
Because the formula, these are all trapezoids. The formula for the trapezoid is half times height.
So the reason why we're multiplying these by 1/2 is the same reason that we're multiplying.
Correct.
That was like an equation that said.
Right. That was because the interval happened to be a half.
Oh, because you're multiplying by whatever the interval. Oh, got it.
So now, let's see what we can factor out of here. Let's see what we can factor out of here. Whoops. what can we factor out? 1/2 times 2. And then what do I have left? 0 plus 2 plus what? Yeah, so 0 plus 2 plus 2 plus root 8 plus thank you. Okay, what conjectures, like what pattern do you see here?
You just add it up.
You can add it up, but look at the numbers. You have 0, 2 and 2, root 8, root 12, 4. They're all double except for the last one, the last and the first. So look at the trapezoids. Look at these vertical lines. In the first trapezoid, the bases are the leftmost one and then this repeats for the second, and then it repeats for the third, and then it repeats for the fourth. So the inside lines are being used twice. One for the trapezoid on the left, one for the trapezoid on the right. The only ones that you only use once is the very left and the very right. So you can use that for the next ones and just say half times the height, base 1, 2 of each of the middle ones, and then the last piece. Okay? So when all is said and done, this is going to be 20.585. So again, nobody writes all this out like this. When we are going to do it the next time, this is how it's going to be. You're going to say area equals half, that's because of the formula, times the height is 2, and then we say 0 plus 2 times 2, 2 times root 8, 2 times root 12, 4. It's cleaner, more efficient, quicker. Okay? That's how we do it. So I only do it at length once, and then we never write it out in that much detail again.
So on the test, we can just write this down.
Yeah, please do. Okay? All right? I can't just go to the one in the black first because, you know, I feel like the first time you need to see it, you need to figure out where it comes from, then you know. Okay? All right, let's do one more. Here is the region R, enclosed between the graph of the function. That's the same thing because it's copied and pasted. So the function y equals negative x squared plus 4 and the x-axis, and notice it's provided for you. For the region 0 to 2, sketch R, it's been done, and use trapezoidal rule to approximate the area under the curve using 4 subintervals of equal length. So, how do we get the height of each trapezoid? What do we do, Shaili?
2 minus 0 over 4, which is 1 half.
Correct.
Can't you just like measure the distance from like where you draw them? Like if you put it on the one on the.
Well, we always like to use general formulas. Of course, you can reason it out too. Yeah. So now we're going to have a half from the formula and a half from the base. So this one,
So we want
yeah. So here we go. 1, 2, 3, 4. This one you're going to have at it on your own. I'll give you about 2 minutes or so. Okay, so go. Thing that I do. Here's one thing that I do. Okay, so tips and tricks.
I must have plugged in my calculator wrong because I did all of that thing.
Tips and tricks. Here's what I do. This is the first x. I call it 0, you know, like the 0th x. And here it's going to be y of 0, y1, y2, y3, y4. So when I write it out, it's going to be half times a half, 1y0 2 of these, 1 y4, and then I know what to plug in. So here it's going to be 2 of y1. Does everybody know where we're getting the values here? The 3.75 and the
I
3.
know you plug it into the negative x squared plus 4. I got it. But
Right.
what, you plug 0.5 in there?
So yeah, so here x is 0.
Right.
I plug it in to the, yeah.
I didn't do it.
Here it's 0.5. I plug it in there, and I get 3.75.
I got 4.5.
5 and 3.43.
When I plugged in,
Because it's
here she
negative.
showed us.
Negatives outside.
Each side. Wait, Christine, can I ask a question?
So let's do the next one. An observer measures the outside temperature every hour from noon to midnight, recording her temperatures in this table. What was the average temperature for the 12-hour period? So we start at noon. So this is my zeroth data. Look, it says everything. This is my zeroth data point. And then I have 1, 2, 3, 4, and then this is the 12th one, right? So it's from noon to midnight. That's what N and M are. Now, the distance between each subinterval, right? That's your time. That's what's going to go on the x-axis. The distance is how much? 1. So that's your height is 1. Okay? That's the distance of, between, that's the length of each subinterval.
Right, you can tell us how many.
Correct. You don't have to do anything. It's all given to you. Yeah.
If the height's 1 for that one subinterval.
But they're all 1. Right? Because this is the x-axis. It goes 1, 2, 3, 4, 5, 6, 7. Correct. Time is going to go on the x-axis, temperature on the y. So the x-axis is your height. So now, the area then, it's going to be half times the height times, now the bases. Now, so where are the bases here? Let me make some space here. Yeah, these are the bases. Right? You just have to copy them down. So area is half times 1. And then 63 plus how many 65s? 2. And 2. It's exactly. It's just like doing the tables in the last lesson. Right? 2 times 68. 2 times 70. 2 times 69.
Where's the second?
Where's the second? Where's the
Well, they're
second
all the
seven?
6. They're all the
Multiple 68.
I just did 166.
It says 2 and 66.
So you use the first and the last one once, everything in the middle twice, right? Remember, because they're each bases of the trapezoids, and they're going to be used for 2 trapezoids.
What does it say next to 2? 7.
I'm just copying down these bases. So 69, 68, another 2 times 68. Did it fit? And then 155. Yes, I made it fit. Okay?
Can we get into your calculator to make it easier?
Yeah.
Can you just add all of the middle numbers and multiply that by 2 and then just add on? So there's only one. Yeah, but everything.
Besides the first and the last number. Finding the mean anyway?
So what we've done here, this is the area. We've just added up all of the different temperatures. So the average temperature is 782 over 12, which is about 65.167. Okay. Next, we have.
Which one would you prefer? Like,
What do you mean?
like in general, like fractions or
Oh no, decimals into 3 decimal places. So next we have a sled powered by a wound rubber band, moves along a track until friction and the unwinding of the rubber band gradually slow it to a stop. A speedometer in the sled monitors its speed, which is recorded at various time intervals. Find the estimated distance traveled using the trapezoidal rule, right? So we need to find the distance. So let's take a look. It's the time goes from 0 to 4, like they're all equal subintervals. So the height is 2. And now you need the distance. The distance, whoops. What we have here is, look, this is important. We have time and speed. So this is going to be time and speed. And the area under a time and speed curve is distance. Okay? So we have to find the area. So again, it's going to be the trapezoidal rule. It's going to be half times 2. And then you need to add them all up.
add all the speeds.
Right, the speeds. Well, and then you have to figure out which ones you have to take 1 of and which ones you have to take 2 of. So I'll give you 2 minutes. So we are going to get about, I believe it's going to come out to 57 feet.
I got 64 points.
Once we've found that, now it says find the average speed. So average speed is total distance over the total time. So hang on. Let me just, I know we can do the numbers. Let's just talk about the physical meaning of the words, of the quantities that we're finding. What we found here, this is the total distance traveled. Okay? And if we want average speed, that's distance over total time. So it's going to be 57 over 18. And what do we get for that? Units? Okay. So this is the trapezoidal rule. The most common mistakes I've seen over the years is students forget the half at the very beginning. Students forget that it's 1 of the end points, 2 of the stuff in the middle. Honestly, these are the most common mistakes I've seen over the years that I've been teaching trapezoidal. So just, be careful about that stuff, all right? Okay, so the homework here is a handout, which I will give you, and it'll also be on haiku, all right?